So we're going to have a look here at how we can use definite integration to find the area beneath the curve. And here we're looking at finding the area enclosed by the by the curve y equals 9 minus x squared and the x-axis. So really we need to do a sketch whenever we've got these questions to be able to visualize what's going on. So 9 minus x squared, I should already know that that's, as a quadratic, is going to have a parabola shape to it. And because it's a negative x squared, it means it's going to be this way around, concave down, as opposed to concave up. So let's just quickly sketch out what that would be like. So I know it's going to have this sort of shape, but I don't know the position of it just yet. If x is equal to 0, I can see that y is equal to 9. That tells me that 9 must be my y-intercept. And similarly, if I make y equal to 0, that means that 9 minus x squared is equal to 0, and I can solve this to give me that x must be equal to plus or minus 3. Those must be my two x-intercepts. So I've got one at negative 3 and one at plus 3. So now I can sketch out what this graph would look like. And I've got a rough indication now. It's only rough, but now I can see what area I'm trying to find. It says the area enclosed, that means fenced off, by 9 minus x squared in the x-axis. So if that's the graph, obviously it continues all the way down here and all the way down here, but the only enclosed bit, the only bit that's completely fenced off all around, with the curve and the x-axis, would be this part in here. And you can see that there's no breaks there, that is completely ringed off, which is what we mean by enclosed. So now what I can do is try and work out what that area is going to be. The way you establish the area is to basically integrate between the upper and lower limit of the upper and lower limit of the area that you want to find. So the upper limit is going to be 3, and my lower limit is going to be negative 3. And I'm trying to integrate, obviously, this graph here, so I'm integrating 9 minus x squared with respect to x. So now I go through and just do my normal definite integration, which is going to be 9 integrated, which is 9x, minus x cubed over 3. Add 1 to the power, divide by the new power. I'm going to integrate that between the limits of 3 and negative 3. So what does that then give me? I get 9 multiplied by 3 minus 3 cubed over 3. That's my first bit, and then subtract from that 9 multiplied by negative 3, subtract negative 3 cubed over 3, like this. So 9 multiplied by 3 is going to be 27. 3 cubed is 27, divided by 3 is 9, so it's 27, subtract 9, minus, I should find in this particular case that I've got very similar calculations on this side. So this time it's 9 multiplied by negative 3, so negative 27, and I've got negative 3 cubed, which is negative 27, over 3 is negative 9, but I'm then going to be subtracting that, so it will become plus 9. So you can see that actually in this particular case the exact same calculations were taking place, but I've just changed this positive to a negative and this negative to a positive. So 27 take away 9 is 18, minus negative 18 overall is equal to 36. And we would normally afterwards just write square units. We don't actually know what the units are, we don't know if we're dealing with centimetres or anything. Normally when we have graphs it's unitless, but we know that whatever the units would be, they would be squared, so that's our final answer.